Saxon Algebra 2, Lesson 73. This is probably not the most exciting lesson you're ever going to study, but it is algebra. It is straight and simple and to the point, and there are 3 examples, my favorite number of examples, and I have no preamble. Let's just dive into a problem and go. We have seen problems like this, similar to this, before. Don't pay attention to the numerator. Look at the denominator. As a mathematician, I know what you're thinking. You're thinking, ew, radicals in my denominator. I can't have that. That's unacceptable. And I agree with you. You're absolutely right. And we learned that we have a special tool that we can use to make these radicals in our denominators go away. It's a thing called a conjugate, which is a fancy name for a really simple idea. The idea is we take the same 2 numbers and we change the sign in between them. Again, the fancy name is conjugate. Conjugates are kind of like reciprocals in that they're 2 numbers that do magical things when they are multiplied together. So we multiply by the conjugates, and because algebra is a balanced world, if we multiply the bottom by this, then we have to multiply the top as well. Now, all of this is exactly the same to what we've already learned. The difference is right here. Before, John was giving us much more simple numerators. He'd just have a single number up there. Now he's giving us another binomial with a radical up top, okay? So what's happened is this is exactly the same, but this multiplication is going to be a little crazier. Now, as I set these up before, what I always do, I set up 2 columns to do the multiplications. Again, let me tell you this. The way that I set up problems is designed to help you remember what comes next. That's one of the hardest parts of algebra, mathematics in general, is remembering what are the steps. I can do them if you'll just remind me, but it's very hard to remember what the steps are. So when I set problems up in a very specific way, it's designed to help you remember what comes next. If we know there are 2 columns, then you'll go, oh yeah, I know I need to multiply the bottoms together. Oh, and then I have to multiply the tops together. 2 columns will help you remember there are 2 calculations. Hey, my mama didn't raise no fools. I do it for a reason, so trust me. Now, I also always multiply the bottom first, because if I've chosen my conjugates wisely, this should turn into a nice, neat little number. So let's try this first and see if it works the way we want it to. Okay, there are the 2 binomials, if you will, the 2 expressions we want to multiply together. And now we do the dance, right? We start down here with this girl. These are the boys. These are the girls. The first girl gets up. She dances with the first boy. 2 times 2 is 4. Then she multiplies with this one. Wolves times wolves, pigs times pigs. Don't you love when my metaphors mix like that? So this will be minus 6 times the square root of 3. 2 is a wolf, 3 is a wolf. Okay, she's done. She's a she-wolf, obviously. She sits down. Now it's her turn. She multiplies this way, and look at the magic that happens. 3 times 2 is 6 times the square root of 3. Notice the opposing signs. That should always happen. If you chose your conjugate properly, this will always happen. This canceling out of the icky stuff. And then we have to multiply this thing together. This is usually the messiest, biggest calculation, but because we see matching pigs, we know it's going to turn out to be a whole number, so I'm going to write it here. First, I'll do the sign. That's going to be negative. Then I'll do the wolves. 3 times 3 is 9. And then I'll do the pigs. 2 pigs of 3 in the house equals 1 out of the house. So it's going to be, this all cancels, 4 minus 27, which is the same as minus 23. I put a squiggle under that because that's going to be the denominator of my ending fraction. But I'm not quite ready to build that yet, so I just squiggle it to go, okay, when I'm ready, I'll come back. That's the bottom of my new fraction. Now we have to do the same thing with the top, and the sad story is we're not guaranteed the same happy outcome, right? Here we knew that conjugate was going to cancel out all of the pig houses, and this last one would just magically resolve itself. In the numerator, we're probably going to be left with a pig house. It's fine. We can cope. 2 times 4 is 8. 2 square root of 3. That's a plus, right? Now I go this way. 12 square root of 3. They do match, so at least I have that. And then this is going to be a whole number, so I can write it over here, or I can go, okay, I know these 2 pigs are going to come out, and so I'm going to put it over here with this 8. I know it'll be positive. I know there'll be the 3 wolf, and then another 3 from those 2 pigs. So this will be 8 plus, this is 9, so this is 17 plus 14 over the square root of 3, and then all of this will be times minus 23. Oh, okay. Now, I don't like this minus sign down here. I'd rather bring it up top, and so what I'm going to do is multiply top and bottom by minus 1. This I'm going to have to remember to distribute, and I will have, I guess I'll squeeze it down here, minus 17 minus 14 over the square root of 3 all over positive 23. This isn't wrong. This is just a more mathematically satisfying way to write the answer. If you gave me this on a test, I would either say that's fine, or I would say, can you get the negative sign out of the denominator for me? And I would let you figure out, oh yeah, you just multiply top and bottom by minus 1. All right. That's how we roll in lesson 73. Let's do it again. There's our problem. One question that students occasionally ask is, do we have to think about this when we're figuring out the conjugate? And the answer is no. When you're finding the conjugate, you're only looking at the denominator. We don't care about the numerator at all. We just want the conjugate of this, and it will be 4 minus 3 times the square root of 2. And then we'll do the same thing up here. Remember, we're doing this not because we're trying to make any magic happen here. We're doing this because we have to do top and bottom the same. And we decided this is going to help with this. So the top just has to take what it can get. The numerator is kind of like the child that just gets the hand-me-downs. They don't ever get to pick out the new clothes, right? The denominator gets to pick out exactly the perfect suit of clothing for itself, and the numerator just has to suck it and deal with whatever's there. Okay, so now we'll do our multiplications. I set them up as columns, so I'll remember, oh yeah, I have to do it twice, and then I have to put them back together. The bottom is the fun one. I mean, if fun is the word you want to apply to this. I think it's fun. This is the one that should turn out perfect. That's why we do it first, is because if it doesn't, we want to catch ourselves before we waste any time multiplying over here. The bottom is where we would catch the mistake. 4 times 4 is 16. This is plus 12 times the square root of 2. 4 times 3 are the wolves, so they go together. And then it's this girl's turn. 3 times 4, they're the wolves, so it's minus 12 square root of 2. Yay, that worked out. Now we know this is going to turn into a whole number, so we're going to do the calculation over here. It'll be minus 3 times 3 is 9. A pair of 2 pigs in the house equals 1 out of the house. So this will be, cancel, 16 minus 18, or negative 2. I'll squiggle it to hold on to it. Now I'm going to go over here and do this multiplication. 4 minus the square root of 2, 4 minus 3 times the square root of 2. Now, the fact that these are both square root of 2's gives me a little bit of hope, but we'll just see what happens. The top is always a wild ride. We don't know what's going to happen. 4 times 4 is 16. 4 times that, okay, this is a wolf, this is a pig, so I can't put them together. 4 square root of 2. Now we go this way. Here are the wolves I can multiply. Minus 12 square root of 2. Well, at least they'll match, right? And I'll be able to put them together. And now we'll put these two together, and this I'm pretty sure is going to turn out to be a whole number, so I'm going to do the work right here. Okay, minus times minus is plus. There's a 3. 2 pigs in the house equals 1 pig out of the house, so this is a 2. So this becomes, this is 6. 16 plus 6 is 22 minus 16 square root of 2. We're adding here, right? So once we determine that these match, we just pay attention to the numbers. All right, now let's look at what we've got. I can see even numbers for days. Can you? So what I want to do, here, I'll write it together so you can see it. That's my top, so I'm going to put it over my bottom, right? Now, what I'd like to do is factor a minus 2 out of the top and the bottom so that I can cancel against the denominator. That's a minus 2. So that's why I'd rather factor out a minus 2 than a positive 2. I'd love to cancel that minus sign if possible. So let's pull a minus 2 out of this. We would have minus 11 plus 8 times the square root of 2 over minus 2. Remember, we can't cancel at this stage because you can only cancel when things are being multiplied. These two numbers are both being subtracted slash added with a negative number, right? Same difference. We can't cancel at this stage. We have to factor first. Now we can factor and cancel, and our final answer will be minus 11 plus 8 times the square root of 2. Yay. Final answer. Okay, one more. That's a whole page. I hope you feel smart when you do something like this, because you are smart. 73.3. Now, this one is a little bit fancier. Okay, there's what we've got. Holy cow. It's a square root party. And I don't want to go, but we have to, so it's fine. Okay, so we could just leap into this and go, okay, here we go, let's find the conjugate, start multiplying everything. That's perfectly fine. We can do that and we'll get the right answer. But if you notice, that radical isn't simplified all the way. And while it's perfectly fine to leave it as a 12 and just do all our multiplications, and in the end we can simplify that radical, if we can simplify in the beginning, it makes our life that much easier because all these calculations will be smaller. And one of my rules of thumb is I like to make my numbers smaller before I make them bigger. So what I would like to do is take this expression, and before I do anything else, I want to simplify it. 12 breaks down, here, let's do this, 3 square root of 12, I'll copy it over. This breaks down into 2 times 2 times 3, right? Because that's 4 times 3. There's a pair of pigs that I can take out. I'm going to bring out a 2 and multiply it here. Those go away. This equals 6 times the square root of 3. That's what's left. All right. Now, I would rather do my calculations using this number than that number. So that's what I'm going to do. I'll go ahead and figure out my conjugate. 3 square root of 3 plus 2 square root of 2. I have to multiply the top by the same. And then I'll do bottom, and then I'll do top. And I'm gonna go ahead and do my bottom multiplication first, but I'm gonna set the top up because I wanna make sure I use this instead of this. So my top rule will be 6 square root of 3. Oh, look at this, minus 2 square root of 3. We can simplify that even more, can't we? This will be 4 square root of 3. And then I just have to multiply that times that. Do you see how things just collapsed even easier? Because when I changed the first radical to simplify it, it matched to the second. And I could do that calculation, right? 6 square root of 3 minus 2 square root of 3. I can actually do that. And I get 4 square root of 3. Now I'm multiplying that times this. All right, I'm going to hold off on that. I'm going to come back over and do the bottom. 3 square root of 3 minus 2 square root of 2. Now this may test your faith in conjugates because that looks like a giant mess, doesn't it? 3 times 3 is 9, plus here's another 3. A pair of 3 pigs jumps out as a single, so this becomes 27. Over here, I see the minus sign. 6, 6. The wolves end up being 6 and the pigs end up being 6. Beautiful. She's done. Her turn. She multiplies this way. Oh, look, it's conjugate heaven. Right? The wolves are a 6, the pigs are a 6. So this all cancels. Goodbye. And then this I can see is going to turn into a whole number. So I'm going to write it here so I can compare it with the 27. It'll be minus 4 times 2 pigs in the house is 1 pig out of the house, another 2. This equals 8, right? So 27 minus 8 equals 19. So that's my new denominator, is 18. All right, now we can go back over to the top. Let me remind you of what we did. We simplified this 12 before we did anything else. We found out that it equals this. Then, when we put this in here and tried to subtract that, we realized, oh, we can actually do that. The radicals match, so we can actually do that. We get 4 square root of 3. And now we just have to multiply. Here, let me write it here too. Equals 4 square root of 3. And then we're multiplying that by this, right? So that's this kind of a shenanigan. 4 times 3 is 12. 2 3 pigs in the house equals another 3 pig out of the house. So that we can multiply in our next step. And then we'll do this one. 4 times 2 is 8. And then the pigs give us a 6. So this becomes, let's see, this is 36 plus 8 times the square root of 6. And now we're ready to put the fraction back together. This is our ending top answer. I get excited because I think we can factor out at least a 2, if not a 4, right? But I look at my denominator and I see a 19 and I go, ooh, that's prime. We can't cancel anything. So my final answer is 36 plus 8 times the square root of 6 over 19. Happy days. Someone rang the doorbell. Gracie woke up and barked. There's a lot of excitement going on here. That's the right answer. Yay. Let me remind you, though, that if you had just been caught up in doing the problem and you hadn't caught that this could be simplified, the problem would look different, but you would still get it right. It would be fine. You would just have to multiply. Well, you just have to deal with that big, ugly 12 in there, and your numbers would get big and messy, but it's fine. It would have worked out fine. All right, who's to say these aren't kind of ugly too? All right, that's it. That's lesson 73. You now are a radical denominator pro, and you're ready for lesson 74. Yay!